All right, so this is problem 2.48. So we've got a wall here, looks like this. Here's water. We know that this is 6 foot here. We know that this is 15 foot here. And this is our point A. And that the force looks like this at A. And we want to know what is the resultant force on a 1 foot wide portion of the wall and its location measured to the right and upward from point A. So they probably want what's the force acting here. Okay, so with everything known here, we can start by saying we have a horizontal force and we have a vertical force. And the force horizontal is going to equal this equation, 1/2 gamma W h squared times 1, because we're looking at a 1 foot wide portion of the wall, and then FV is going to be 1/2 gamma W. We could say this is going to be, it's listed as BA times 1, but we could say that this is going to be H times, we already have this, so I'm going to say that's our width. I'm going to say length times 1. Pretty much it's the gamma V that we learned here. So now that we know that, we can start plugging into FH and FV. And mostly this problem is going to be teaching us how to get our angle and how to get a resultant force from a horizontal and a vertical force. So 1/2 62.4 times 15 squared times 1, but I'm not going to write the times 1. 1/2 62.4 times 15 times 6. And now we can plug all this in. $70.20 and 1/2 62.4 times 15 times 6, 2808. Now, this is what the problem's really asking. The force resultant, I think is what they want it to be labeled as, is going to be, maybe we can just call it F. FH squared plus FV squared. The square root of those. So if we just take a square root of 7020 squared plus 2808 squared, we get 7560. And what is this going to be? Pounds. These are all in pounds. So divide this by 1,000 pound per kip. We have 7.56 kip. And the next thing it asks us is, what is the angle here? So tan inverse theta is going to be, or did I write that backwards? Should be theta? Yeah. Theta equals tan inverse of FV over FH, y over x. So if we plug this in to our calculator, we just do inverse tan of our FV, which is 2808, over our 7020. And we get an angle of 21.8 degrees. And where is this? This angle is in the positive coordinate here. So right there is our force at A, and right here is our angle at A. And remember, this equation and that equation are really the big takeaways from this problem. So thank you guys for watching.